So, this is a video which explains the solutions for assignment 6 and 7, the assignment for week 6 and week 7. I am going to choose a few representative problems and work them out in detail. The answer key is already with you. Hopefully, these problems that I pick will help you in knowing the techniques and the steps involved in solving the problems, and hopefully this will be of use to you. Okay, so let us begin with the week 6 assignment. Okay. So, I will start with the first question. The first question has f of t equals e power minus a t times 2 sine squared omega c t times u of t. Okay. And you have to find the Fourier transform. So, this is a signal that is given to you. You have to find the Fourier transform of this signal. Okay. So, that is the question. The most important things to have when you want to find Fourier transform is a table of basic Fourier transforms and a table of properties of Fourier transform. Once you have these two tables, you can use those and solve these kind of problems. Okay. So, now if you look at the table, most tables for Fourier transform will have this. So, from the table you can see there is a basic Fourier transform pair which is kind of close to this, but not exactly that. Okay. So, e power minus a t cos say omega naught t, okay, times u of t Fourier transforms to, I guess let me use something else here, I will use alpha here, e power minus alpha t cos omega naught t u of t transforms to alpha plus j omega divided by, I am sorry, j omega naught, no j omega, sorry, it is alpha plus j omega divided by omega naught square plus alpha plus j omega whole square. Okay. So, this is a Fourier transform that you can get from the table. So, now the idea is to start with this f of t here, okay, and then use some trigonometric identities and convert it into a function of this form. Once you do that, one can write down the answer without too much work. Okay. So, let us try and do that. So, f of t is actually e power minus a t times 2 sine squared omega c t. So, now we know 2 sine squared omega c t is actually 1 minus cos 2 omega c t. Okay. So, this is the trigonometric identity that I am using. Okay. So, this guy gets replaced with this. Okay. So, that is a standard trigonometric identity. Cos 2 theta is cos square theta minus sin square theta. So, you replace cos square theta by 1 minus sin square theta. So, you see cos 2 theta as 1 minus 2 sin square theta, and so from there you can write this directly. Okay. So, that is the first step. Now, one can simplify this to e power minus a t u of t minus e power minus a t cos 2 omega c t u t. Okay. So, it is quite easy from this point on. Okay. From here on, it is quite a simple thing to do. You have to just do a Fourier transform. If you do a Fourier transform from here, there is also another result. If you want, you can write that down, e power minus alpha t u t. This has a Fourier transform which is 1 by alpha plus j omega. Okay. You can put omega naught equal to 0 here and you get this. Okay. So, you use these two results from the table. So, you can see you can write the Fourier transform simply 1 by a plus j omega minus a plus j omega divided by 2 omega c whole squared plus a plus j omega whole squared. Okay. So, that is the Fourier transform. So, now okay, so maybe you want to combine these two things, simplify these guys a little bit. You will have here a plus j omega times 4 omega c squared plus a plus j omega whole squared. Okay, what will come in the numerator? You will get 4 omega c squared plus a plus j omega whole squared minus a plus j omega whole squared. Okay, so this will cancel and you end up getting the answer 4 omega c squared divided by a plus j omega times 4 omega c squared plus a plus j omega whole squared. Okay, so that's it. So the entire problem is solved by using the table and then doing a few basic manipulations to get what you want. Okay, so that's the first question. So I'm going to do the second question as well. So in this question, f of t is given in terms of a plot. Okay, it's a triangle signal. This is f of t versus t. It's a triangle going from 0 to d, and the peak is at d by 2, and this is a. Okay, so this is the signal for which you have to find the Fourier transform, and so there's various ways of doing it. One could start with the Fourier transform for the triangle wave and then use that. So, for instance, in many tables you will find the following Fourier transform. For the triangle wave there might be some Fourier transform that is known, but let me just see for 1 minute if we can do anything else here which is interesting. No. So, let me just use the. So, a standard signal is something like this triangle, let me call this triangle of t. This is going to start at let us say minus half, go up to 1 and then come back to 0 at half. Okay. So, this is a standard sort of signal, and maybe we need to keep it a little bit more generic. So, maybe we will keep it minus t by 2 to t by 2, but it goes up to 1 and comes down. Okay. So, this is a generic triangle, and you might want to find the Fourier transform for this guy. Okay. So, the Fourier transform for this will have a sinc square function, I believe. So, one needs to look at that very carefully. I think it will be sine, the Fourier transform of this is going to be sine omega t by 4 by omega t by 4 whole square times t by 2. Okay, so I think that's going to be the Fourier transform of this guy. Okay, so once you have this Fourier transform, this is from the table, let us say. Okay, one can also derive this without too much confusion, but let's just keep it as the answer from the table. Okay, so once you have this, it's a question of taking this f of t and then moving it around so that you can write it in terms of triangle of t. Okay, so what you do first is to move this, write this f of t in terms of the triangle. So if I want to do the triangle here, so if you move this triangle around to the origin, okay, so if you move it to the origin, what do you get? If you move to the origin, you get minus d by 2, and then this is a. So I'm shifting left by d by 2. Okay, so I get this signal, and this one looks close to the triangle. In fact, you can write this as a times the triangle, right? Okay, so I need a bit of a parameter here, so I can call this triangle with a parameter t. So this is a times triangle with the parameter d of t. Okay, so that's the trick. So you write the given f of t in terms of the standard triangle for which you know the Fourier transform, and then you can directly use the table to get your answer. Okay. So this f of t when shifted left by d by 2 becomes a times triangle with d of t. Okay. So this capital T is like the width of the triangle. Okay. Okay, width or base of the triangle. So here the base is small d. Okay. So that's the difference between these two things. So now how do you write f of t in terms of the triangle? F of t is simply a times triangle D of t delayed by d by 2. Okay. So, this is a crucial relationship. Okay. So, this is an important relationship. Once you have this relationship, most of your work has been done. Okay. After this, it is a question of using the properties of the Fourier transform and the standard table from which you got this response, this Fourier transform pair, and then you are done. Okay. So, that is it. So, once I do this, what would I get? If I have to transform this, I am going to get f of j omega equals a times. So, now notice this is t minus d by 2. So, I need to multiply by e power minus j omega d by 2, right, and then just make sure I get that right, omega d by 2 times. Now, I have the Fourier transform of triangle with base d, and that is simply d by 2 sin omega d by 4 by omega d by 4 whole square. Okay. So, if you want, you can move this around and write it as e power minus j omega d by 2 times a d by 2 times this same kind of sinc square expression. Okay. So, that is it. Okay. So, the basic idea is you know the Fourier transform of the standard triangle function. You write the given triangle function in terms of the standard triangle function. You might have to shift it, you might have to scale it sometimes like you did here. Sometimes you might have to do a time shift or something like that. So, once you do that, you will get it in this form. Once you get in this form, it is a question of using the standard properties of the Fourier transform to get the actual expression. Okay. So, that is the second question for you. So, the third and fourth question are directly from the properties. I am going to skip that, and the fifth one also is. So, let me see. Maybe I will do the fifth one. Okay. So, we will pick the fifth one for you. Okay. So, the fifth one says a signal f of t is given below. It is actually a square wave, square signal with this d from minus d by 2 to d by 2, and the height is a. This is f of t. Okay. So, this is given to you. What is the Fourier transform of e power j omega c t? Question asks you to find the Fourier transform of e power j omega c t times f of t. Okay. So, the first thing you need to start with is the Fourier transform of f of t itself, and once again this you can find from the table quite easily. This is going to be a d, I think. Okay. So, a d times sin omega d by 2 divided by omega d by 2. Okay. So, this is the formula for f of t. If you want, you can cancel the d and write it differently, but it is standard to write it like this: a times d sin omega d by 2 by omega d by 2. This is the Fourier transform for f of t. So, what will be, so let us say we call this as f of j omega. Okay. So, what will be the Fourier transform of e power j omega c t times f of t? There is this standard property which says if you multiply by e power j omega c t, the Fourier transform becomes f of omega minus omega naught. So, this is going to be f of j omega minus omega naught. So, wherever you have omega in the Fourier transform, you have to put omega minus omega naught. So, this just becomes a times d sin omega minus omega naught d by 2 divided by omega minus omega naught. Okay, it is not omega naught, it is omega c. I am sorry, I guess that needs to be done here because it is e power j omega c t. So, sorry about that, it is omega c, omega minus omega c by 2 times d. Okay, so, that is the answer, and that is one of the options given in the question. Okay, so, that is the answer for the fifth question. So, let me see which else, what else I can do. So, you see many of these questions are simple applications of the properties, but you have to just identify which one to use from the table of properties and use it, that is it. Okay. The next question I want to try is maybe the 7th one. It is also quite easy. You have a Fourier transform pair f of t and f of j omega, okay, and you have to find the Fourier transform pair corresponding to the second derivative d square f of t dt square, okay, which is also written as f double prime of t. What is this going to be? Okay. So, now from your properties you know that f prime of t is going to be minus j omega, is it right? If you look at the properties, differentiation in time is not minus, it is just plus j omega times f of j omega. So, you look at the properties, you get that. Okay. So, now what is f double prime of t? It is actually d by dt of df by dt, right. So, it is nothing but f prime of t the whole prime. Okay. So, now you use the same property again on f prime of t. You have to say this is actually j omega times the Fourier transform of what, of f prime of t, right, and that is simply j omega times j omega f of j omega, and that will evaluate to minus omega squared f of j omega, which I hope agrees with the key. Yes, it does. Okay, so that is the idea. So, you repeatedly use the differentiation property, you can do any derivative. Now, if you want to do the third derivative, you once again use this, multiply it by j omega, you will keep getting the third derivative, fourth derivative and so on. Okay, so that is the idea. That is question number 7. Now, let me see what else I can look at. Okay, so, the energy of the signal, it is good to know definitions for the energy of a signal. Energy of a signal is defined as integral minus infinity to infinity absolute value of f of t squared dt. Okay. You can use this famous Parseval's relation, which says this is the same as 1 by 2 pi integral minus infinity to infinity absolute value of x of j omega squared d omega. Okay, so, this is called Parseval's relation, and this is used in quite a few of these questions. Okay. And okay, so this is used in question number 8 and question number 10 and so on. So, maybe I will do question number 10 for you. Okay. So, what is the 10th question? It says you are given the Fourier transform of a signal. Okay. So, there is f of t, it Fourier transforms to f of j omega, which is given as e power minus 2 omega for omega greater than or equal to 0, and it is 0 for omega less than 0, and you have to find the energy, okay, energy in the signal. So, now we know energy given f of t, you can do integral from minus infinity to infinity absolute value squared. Given the Fourier transform also, you can use the same formula. So, you use Parseval's relation, this is minus infinity to infinity absolute value of f of, okay, so I am writing f here and x here, I am sorry, f of j omega squared d omega. So, now it is just a question of using this particular f of j omega here and evaluating this integral. So, I know for this particular j omega, it is just 0 to infinity e power minus 2 omega whole square d omega, which is nothing but 1 by 2 pi integral 0 to infinity e power minus 4 omega d omega, and that is nothing but 1 by 2 pi e power minus 4 omega by minus 4 evaluated between 0 and infinity. At infinity, this is going to go to 0, right, it is going to go to 0, and minus at 0, it is going to be 1 by minus 4. So, the value ends up being 1 by 8 pi. Okay, so, that is the answer. So, it is just most of these questions are basic integration or differentiation questions with energy, it is not too hard to do. Okay, so, that is question number 10 for you. Question number 11 is again, so maybe I will do 11 as well because it uses two properties. So, you are given a basic Fourier transform pair f of t and f of j omega. You need to find the Fourier transform of g of t, which is actually df of minus 2t by dt. Okay. So, first you can find the Fourier transform of f of minus 2t, that is going to be 1 by 2 f of minus j omega by 2, right. F of at, there is a property for f of at is 1 by mod a f of j omega by a. Okay, so, that is 1 f of 2t. So, now derivative, again you can use take the Fourier transform of f of minus 2t and multiply by j omega. So, you get j omega by 2 times f of minus j omega by 2. Okay, so, that is the formula. So, you just keep using the properties one after the other, you are going to get what you want. Okay. All right, that is 11 for you. Okay. So, 12th question is also an energy question. So, let me do that. Have f of t being e power minus root 3a mod t. Okay. And you have to find the energy of the signal. You can do it in multiple ways. One can use the Fourier transform if you like for evaluating the energy, or one can directly do it in the time domain as well. It is not too problematic that way. So, let me just see, this is easy to do. So, you have f of t is e power minus root 3a mod t. This is actually quite easy to do in time domain itself. So, if you want to find energy, this is going to be integral minus infinity to infinity mod f of t squared dt, and this you can write it as my integral minus infinity to infinity e power minus root 3 a t absolute value of t whole square, right. So, exponential is a positive function. So, e power minus root 3 a mod t whole square, and now this guy is an even function, right. This is even. So, you can write it as 2 times integral 0 to infinity e power minus 2 root 3 a t dt. Okay. Once you do this, this is just a standard integral e power minus 2 root 3 a t by minus 2 root 3 a 0 to infinity, and that will evaluate as 2 times 0 minus 1 by minus 2 root 3 a, and that is just 1 by root 3 a. Okay. So, from there you see the answer that you want is 3. Okay. So, that is the answer. Sometimes these things can be easy in the time domain itself, you do not have to necessarily go to the Fourier domain to do these problems. Okay. So, the next question I would like to do is 13 for instance. Okay. There is a signal f of t which is 1 by 2 pi, it is given in terms of sinc t by 2 pi, okay. And this is passed through a filter of this form. Okay. So, this goes through a filter of the form given here. So, h of j omega is basically minus 1 by 4 to 1 by 4, the height is 1, this is h of j omega versus omega. Okay. And you have to find the output signal, and what is asked is the ratio of the output energy to input energy. Okay. So, you have to find the input energy. So, for that let us say look at the Fourier transform of f of t. This guy I believe goes from minus half to half, okay, and the height is 1. Okay. So, this is the important thing, what f of j omega, the height is 1, the constants have been adjusted to give you exactly that. Okay. So, that is the f of j omega. Now, the question is what is g of j omega? G of j omega we know is equal to f of j omega times h of j omega. Okay, it's just the product. If you multiply these two things, you're simply going to get the same, right. So, minus half to half, you multiply by this guy, it's 0 from minus half to 1 by 4, 0 from minus half 1 by 4 to half, and it is 1 only between minus 1 by 4 and 1 by 4. So, what will survive is actually just minus 1 by 4 to 1 by 4 at height 1. Okay. So, now for finding the input energy and output energy, you can use the Parseval's relation. The input energy is 1 by 2 pi integral minus infinity to infinity absolute value of f of j omega squared d omega. F of j omega is simply 1. So, this is just 1 by 2 pi from minus half to half 1 d omega, and that is just the area under this thing here, which is just 1. So, it is just 1 by 2 pi. On the other hand, here the output energy is 1 by 2 pi integral minus 1 by 4 to 1 by 4 of 1 d omega, right. So, absolute value of j omega squared, and this is 1 only from minus 1 by 4 to 1 by 4. So, you get 1 by 2 pi into a half. Okay. So, that is the answer. So, if you want to find ratio of output energy to input energy, you are going to get the answer 1 by 2. Okay. So, the ratio of output energy by input energy equals 1 by 2. Okay. So, the crucial thing is this kind of problem can be done very easily in the Fourier domain, because filtering is just a product of the transforms. Okay. So, so if you look at the remaining problems, 14 I will skip and I will look at, okay, 15 is also a standard problem. So, I'm going to stop here. So, 14, 15 and 16 are just from the tables. You have to look at the Fourier transform tables and pick the constants that you have. Okay. So, thanks a lot, and that brings us to the end of a discussion of the solutions of problems in assignment for the week 6. Okay, thank you.